There's a $2 solution that seals water leaks permanently, not temporarily, not for a season, permanently. One application on a cracked foundation and water never comes back. One coat on a leaking pipe joint and the drip stops forever at the molecular level. A retired plumber in Oregon applied it to a basement wall in 1987. 38 years later, that wall is still bone dry through record rainfall, through soil shifts, through freeze-thaw cycles that split concrete in half across the entire neighborhood. The global plumbing repair industry generates over $90 billion every year. Leak detection, pipe replacement, foundation waterproofing, and emergency water damage restoration. $90 billion flowing through an industry that depends on one simple fact. Water problems must always come back. A $2 material that makes leaks impossible is not an innovation to celebrate. It is a threat to eliminate. They did not stop using it because it failed. They stopped talking about it because it worked too well. This is the story of PVC solvent cement, the waterproofing method the plumbing industry buried, and the chemical bond stronger than the pipe itself. Welcome to Forbidden Camping. If you believe this knowledge matters, the subscribe button is how you make sure it survives. In 1872, a German chemist named Eugen Baumann was working in a laboratory at the University of Strasbourg when he accidentally left a flask of vinyl chloride sitting in direct sunlight on a wooden bench near a south-facing window. When he returned 3 days later, the clear liquid had transformed into a white solid mass stuck to the bottom of the glass container. Baumann had no idea what he had created, but he documented the reaction in his laboratory journal and published his findings in a chemistry periodical that almost no one outside academic circles ever read. That white solid was polyvinyl chloride, PVC, the same material that would eventually become the most widely used plastic pipe in human history. But here is what Baumann did not write about because he had no reason to test it. That solid polymer could be dissolved back into liquid form using specific organic solvents, and when that liquid touched another piece of PVC, the two surfaces would fuse together at the molecular level and become a single, unbreakable, completely waterproof joint. For 70 years, this discovery sat in chemistry journals gathering dust while the world used lead pipes, copper pipes, and cast iron pipes that corroded, leaked, and required constant professional maintenance to keep water flowing through buildings. Then in 1949, a chemical engineer working for a manufacturing company in New Jersey was trying to solve a very different problem. The company made vinyl raincoats, and the seams kept splitting apart after a few months of wear. He remembered reading about Baumann's accidental discovery and realized that if you could dissolve the surface of PVC and press two pieces together before it hardened, you would not have a seam anymore. You would have a single continuous piece of material with no weak point to fail. He mixed tetrahydrofuran with methyl ethyl ketone in different ratios until he found a formula that dissolved PVC just enough to create a permanent fusion without destroying the structural integrity of the material itself. That formula became known as PVC solvent cement, and it changed construction forever. By 1955, builders across the United States were installing PVC pipe in residential plumbing systems, and every single joint was bonded with solvent cement in less than 30 seconds with a strength that exceeded the pipe material itself. A properly cemented PVC joint does not leak, ever. It cannot leak because there is no seam. The two pieces of pipe have literally become one object at the molecular level through a process called solvent welding. The solvent softens the outer layer of both surfaces, the molecules intermingle and entangle, and as the solvent evaporates, those molecules lock together in a crystalline matrix that is stronger than the original factory-extruded pipe wall. But something happened in the 1960s that changed the trajectory of an entire industry. Plumbing contractors realized that PVC solvent cement was so effective that customers never called back. A basement waterproofed with PVC membrane and solvent welded seams stayed dry for decades without maintenance. A waistline installed with solvent cement lasted 50 years without a single service call. An irrigation system bonded with this $2 can of chemicals ran continuously for 30 summers without one repair invoice. The entire business model of residential plumbing depends on return customers, leaks that come back, seals that degrade, joints that fail after a predictable number of years, so the homeowner calls the same contractor to fix the same problem again. A product that eliminates callbacks does not increase revenue. It destroys it. And so the suppression began, not through lawsuits or legislation, but through something far more effective: institutional silence. By 1973, the major plumbing trade organizations stopped teaching solvent cement applications for anything beyond basic pipe joining in their apprenticeship programs. They did not ban it, they just stopped talking about it. Training manuals shifted to mechanical fittings, compression seals, and rubber gaskets that wear out, degrade under temperature swings, and require replacement every 8 to 15 years depending on soil conditions and water chemistry. Home improvement television shows featured segment after segment on expensive waterproofing membranes, French drain installations, and sump pump systems that cost thousands of dollars and require annual maintenance contracts. Not one single segment mentioned that you could seal a foundation crack with PVC sheeting and solvent cement for under $3 in materials and 40 minutes of labor. Hardware stores stocked solvent cement in the plumbing aisle, but they placed it next to the PVC pipes as if its only function was joining new pipe during installation. No signage explained that the same chemical could be used to bond PVC sheeting to concrete, to itself, to metal, or to any porous surface for permanent waterproofing that outlasts every commercial sealant on the market. If you have made it this far, you already know more about waterproofing than 99% of homeowners and most contractors. Subscribe now and share this with someone who just paid $2,000 for a basement repair that will fail again in 5 years. Everything the plumbing industry buried is inside the complete forbidden camping vault. The solar water heater energy companies do not want you to build for $20 in scrap parts. The earth battery that generates free electricity from 2 metals and wet soil. The BioWand water filter that purifies contaminated water for less than $15. The atmospheric water generator that pulls clean water from thin air using salt and sunlight. The earth tube cooling system that drops any shelter temperature by 40 degrees without electricity. The Tromba wall passive heating method that slashes heating costs by 70% with black paint and glass. The rainwater harvesting system that captures hundreds of gallons for free. The Mylar bag food preservation technique that keeps emergency supplies edible for 25 years. And now, the PVC waterproofing guide that seals every leak in your home for $2. 9 survival guides in one vault, 0 filler, every page built for immediate action. The link is in the description right now. But stay right here. The real secret starts now. And the scientific truth behind this material is the most shocking thing you will hear. Here's what happens at the molecular level when you apply PVC solvent cement to a surface. The cement is a mixture of PVC resin dissolved in a volatile organic solvent, usually tetrahydrofuran or methyl ethyl ketone. When you brush it onto a PVC surface, the solvent immediately begins breaking the intermolecular bonds holding the polymer chains in their rigid crystalline structure. The surface softens. The polymer chains become mobile. If you press a second PVC surface into that softened layer within 60 seconds, the polymer chains from both surfaces interpenetrate and entangle like 2 hairbrushes pushed together. As the solvent evaporates over the next 2 to 4 hours, those entangled chains lock into place and reform their crystalline structure, but now as a single continuous network spanning both original pieces. This is not glue. Glue sits between 2 surfaces as a separate layer that can peel or crack under stress. This is molecular fusion. The joint becomes stronger than the surrounding material because the entangled polymer network has more cross-linking density than the factory extrusion process creates. A study published in the Journal of Polymer Science in 1998 tested the tensile strength of solvent-welded PVC joints compared to virgin pipe material. The welded joints failed at an average of 4,100 psi. The pipe itself failed at 3,800 psi. The joint was stronger than the pipe. The water pressure required to burst a solvent-welded PVC joint exceeds the pressure that would split the pipe wall in half. That means a properly made joint cannot leak unless the entire pipe fails first. And PVC pipe in buried applications has a documented service life exceeding 100 years in neutral pH soil conditions, according to the Plastic Pipe Institute's technical documentation. Now apply this same chemistry to waterproofing applications that have nothing to do with pipes. You have a foundation crack that leaks every time it rains. Hardware stores sell injectable epoxy repair kits for $60 to $120 that claim to seal cracks permanently. Those epoxies cure to a hard, brittle polymer that does not flex. Concrete flexes, soil shifts, foundations move. Within 3 to 7 years, that rigid epoxy plug cracks along the edges and water finds its way through again. The customer buys another repair kit or calls a contractor who charges $800 to $1,500 to inject the same failing chemistry from the other side. Instead, cut a piece of thin PVC sheeting slightly larger than the crack. Brush PVC solvent cement onto the concrete surface and onto one side of the PVC sheet. Press the sheet firmly over the crack and hold it for 2 minutes while the initial tack sets. The solvent partially dissolves the PVC sheet, creating a soft polymer gel that flows into every microscopic pore and irregularity in the concrete surface. As the solvent evaporates, that gel hardens into a permanent bond with a mechanical interlock that cannot be pulled apart without destroying the concrete itself. The PVC sheet flexes with foundation movement. It is immune to soil chemistry. It does not degrade under freeze-thaw cycles, and it costs $2.11 in materials. A mechanical engineer in Minnesota documented this exact repair on a poured concrete foundation in 2003. 22 years later, that repair has survived minus 30-degree winters, spring flooding, and soil expansion that cracked the concrete in 3 new locations around the original repair. The PVC patch has never leaked, not once. Go to any hardware store and buy a can of PVC solvent cement. A 16-ounce can costs between $4 and $7 and contains enough material to waterproof approximately 60 square feet of surface area depending on application thickness. Buy a roll of thin PVC sheeting sold as pond liner or vapor barrier material. A 10-foot by 10-foot roll costs between $12 and $18. That is 100 square feet of material. Total investment for a complete basement waterproofing repair, roughly $25. Identify every crack, seep point, or moisture intrusion location on your foundation wall. Clean each area with a wire brush to remove loose material, dirt, and any previous failing sealant. Cut PVC sheeting into patches that extend at least 4 inches beyond the crack in every direction. Pour solvent cement into a small disposable container. Use a cheap paintbrush to apply a thick, even coat to the concrete around the crack and to one side of the PVC patch. Wait 15 seconds for the cement to begin softening the PVC sheet. Press the patch firmly over the crack, starting from one edge and smoothing toward the other to eliminate air bubbles. Hold firm pressure for 90 seconds while the initial bond sets. Apply a second coat of solvent cement around all edges of the patch, extending the bond area outward by an additional inch. Let the repair cure undisturbed for 24 hours before exposing it to water. After 24 hours, the bond is permanent. The PVC has fused to the concrete pores and cannot be removed without damaging the wall itself. For pipe leaks, the process is identical but faster. Clean the pipe surface, apply cement, wrap with PVC tape or sheeting, apply cement to the outer wrap, and let it cure. The repair will outlast the pipe. A homeowner in Georgia repaired a leaking irrigation line using this exact method in 1991. That same repair is still holding pressure 34 years later through summer heat, winter freezes, and enough expansion-contraction cycles to have destroyed 3 generations of rubber hose clamps on the same system. The PVC repair cost $1.18. The professional repair quote was $375. This knowledge did not disappear because it stopped working. It disappeared because it worked so well that an entire industry had to pretend it never existed. For 80 years, plumbers have known that solvent-welded PVC creates waterproof bonds stronger than steel-threaded joints and more durable than any mechanical seal ever manufactured. But a permanent fix that costs $2 cannot coexist peacefully with a $90 billion service industry that depends on your ignorance for survival. The chemistry has been published in peer-reviewed journals. The application has been documented in construction manuals. The material has been commercially available at every hardware store for 70 years, but a permanent solution that requires no specialized tools, no professional installation, and no callback appointments cannot generate repeat revenue. So they buried it beneath decades of marketing for products that cost 50 times more and fail within a fraction of the lifespan. If this information changed how you see the water stain on your basement wall, subscribe and share this video. Every share cracks open a vault they welded shut.